Welcome to The Explainer. Today we're unpacking something that honestly just blows my mind. One of the most magnificent, monumental forces of nature on our entire planet. We're going on an epic journey to trace the great Indian monsoon. We're going to follow this massive system all the way from its quiet birth in the changing pressures of the atmosphere to the vital cascading rains it delivers across the subcontinent, and finally look at the very modern threats that could disrupt this ancient cycle forever.
Here's our roadmap for this explainer. We're going to kick things off with the monsoon mechanism. Then we'll track the Arabian Sea branch, followed by the Bay of Bengal branch. After that, we'll look at the retreating monsoon season, and finally, we'll wrap up with the threat of global warming.
All right, let's dive right into part one, the monsoon mechanism, the birth of the wind.
So our story actually starts in May, hovering over the northwestern plains of India. Down on the ground, a rapid, intense temperature increase essentially creates a massive, incredibly powerful low-pressure zone. Which brings up a really fascinating question. How exactly does a wind system define a nation? Because by early June, this low-pressure zone gets so intense that it literally acts like a giant vacuum, dragging the trade winds from the southern hemisphere all the way across the Indian Ocean. This isn't just some background weather event. It's an active, powerful character that dictates agriculture, drives the economy, and sets the very rhythm of daily life for an entire subcontinent.
To really grasp the sheer scale of this absolute beast of a weather system, meteorologists actually have to look thousands of miles away. It's wild to think about, but to measure the intensity of the Southwest Monsoon winds, scientists calculate the atmospheric pressure difference between Tahiti, way out in French Polynesia in the East Pacific, and Port Darwin in northern Australia. A shift in pressure happening over the deep Pacific Ocean quite literally dictates the amount of rain falling on the streets of Mumbai. It's like a massive, interconnected global seesaw.
And to tame all that global atmospheric chaos into a predictable science, the Indian Meteorological Department doesn't just rely on guesswork. They monitor exactly 16 key indicators. That's 16 distinct, incredibly complex data points used to forecast how these massive wind systems might behave long before a single drop of rain ever hits the ground. It's a monumental scientific effort just to give millions of people a heads up on the season to come.
Which brings us to part two, the Arabian Sea branch, a three-pronged arrival.
As those southeast trade winds we just talked about cross the equator, they pass over warm ocean currents and scoop up a ridiculous amount of moisture. When this Arabian Sea branch finally hits the coast, it doesn't just hit as a single wall of wind, it actually strikes in three distinct simultaneous paths. First, the main thrust smashes directly into the towering Western Ghats. Second, another path strikes north of Mumbai, funneling straight down the Narmada and Tapi river valleys to water central India. And third, a northern sweep crosses the Saurashtra Peninsula and Kutch, dropping only scanty rainfall over West Rajasthan before pushing on toward the Himalayas. But let's zoom in on that first path, striking the Western Ghats for a second, because it perfectly illustrates a super important geographical concept, the rain shadow area. When these monsoon winds hit the mountain slopes, they're forced upwards of 1,200 meters. They cool rapidly and just dump a staggering 250 to 400 centimeters of heavy rain on the windward side. But after crossing those peaks, the winds descend, heat up, and entirely lose their humidity. Because of this, the region just east of the mountains remains almost completely dry. It's a textbook example of how geography literally dictates entirely different climates for folks living just a few miles apart.
Meanwhile, over on the other side of the country, we've got part three, the Bay of Bengal branch, the eastern sweep.
The second massive arm of the monsoon initially heads toward the coast of Myanmar and southeast Bangladesh. But then, something amazing happens. It hits the Arakan Hills, and a huge chunk of this system gets deflected right back into the Indian subcontinent. It sweeps up the Brahmaputra Valley, creating a massive geographical funnel for extreme moisture over the Garo and Khasi Hills of Meghalaya. Because of this exact deflection, Mohsin Ram, a town located right on the crest of those Khasi Hills, receives the highest average annual rainfall anywhere in the world. Just imagine living in literally the wettest place on Earth, entirely because of how a wind bounces off a distant mountain range. But this sets up a really cool micro-mystery for us. While Mohsin Ram is busy breaking global world records for extreme rainfall in the Northeast, why on earth does the Tamil Nadu coast, further south, stay completely bone dry during this exact same Southwest Monsoon season?
Well, the answer to this mystery lies in two simple, unchangeable spatial facts. First, the Tamil Nadu coast is situated totally parallel to the Bay of Bengal branch, meaning those heavy, rain-bearing winds just slide right on past it along the coastline without ever striking land. Second, it's tucked perfectly inside that rain shadow area of the Arabian Sea branch we learned about a minute ago. So by a total quirk of geography, this region manages to completely dodge both of these massive moisture-laden systems entirely. Pretty wild, right?
That brings us to part 4, the retreating monsoon season. The wind withdraws.
So, in the traditional Indian calendar, the year is elegantly divided into 6 seasons. By October and November, as the sun begins to shift, that intense low-pressure trough over the Ganga Plains starts moving southward. We can actually track this retreat chronologically across the map. By early September, the monsoon pulls back from western Rajasthan. By the end of September, it completely withdraws from Gujarat and the Central Highlands. Moving into early November, that low-pressure center has drifted over Karnataka and Tamil Nadu until mid-December, when the entire system is completely gone from the peninsula.
But don't be fooled. Even while retreating, the monsoon still packs an incredibly powerful punch. While it leaves North India dry, it brings widespread heavy rain to the eastern part of the peninsula. This is driven by massive cyclonic depressions that originate over the Andaman Sea. These depressions cross the eastern coast, hitting the Coromandel coast hard, which means, ironically, October and November, the months when the monsoon is theoretically leaving, actually become the rainiest months of the whole year for the southern peninsula.
Now we must turn to our final and definitely most critical chapter, Part 5, the threat of global warming, breaking the cycle. This intricate, ancient, beautifully balanced machine delivers a vital 125 centimeters of average annual rainfall to India. But right now, it is facing an unprecedented disruption from rising global temperatures. The chemical drivers of this change are entirely clear. We know human activities, primarily the burning of fossil fuels, are releasing massive amounts of carbon dioxide. But what's really concerning are trace gases like methane, chlorofluorocarbons, and nitrous oxide. Even though they're present in much smaller concentrations, these specific gases punch way above their weight. They are highly effective absorbers of long-wave radiations, meaning they supercharge the greenhouse effect. They trap the heat, warming the oceans and aggressively melting polar ice caps and mountain glaciers.
And all that melting leads us to a crucial, highly alarming number, 48 centimeters. According to current predictions, because of this glacial and sea ice melting, average global sea levels will rise by 48 centimeters, almost half a meter, by the end of the 21st century. This isn't just a distant abstract statistic for a textbook. This guarantees a drastic increase in devastating annual floods across coastal and low-lying regions. It means entire communities facing rising waters year after year.
And the consequences extend far beyond just rising water levels. This climatic shift will promote insect-borne diseases like malaria and literally shift our existing climatic boundaries, making some previously lush regions suddenly drier and other regions unexpectedly dangerously wetter. The ancient, reliable rhythm of the wind is breaking down. As these boundaries shift, we have to ask ourselves, how will this fundamentally change our future, and what actually happens when the wind system that defines a nation loses its balance? Thank you so much for exploring the mechanics, the mystery, and the fragile future of the Great Indian Monsoon with us in this explainer. Keep questioning and keep learning.